Hey, thanks for tuning into the Unit 7 video where we're going to review similar figures. Now this unit was a crowd favorite. A lot of you did very, very well in this unit. So this video should be relatively short and sweet and to the point. We're just going to go over a few examples here. A few things to review in terms of just what we're looking at in the language of algebra. This little symbol right here means similar, okay? So this we're just saying that triangle RST is similar to triangle XYZ. All right, so we have RST and then XYZ. What that means is that the measure of angle R is the same as the measure of angle X. And I wanted to remind you guys that because R is in the first spot, it corresponds to angle X. So I could say that angle R has the exact same measure as angle X. So that's what that symbol looks like. Now we're saying that the measure of the two angles actually equals each other in the similar figure, okay? Now the question here is asking us to find the length of ZY right here. Now I'm going to use my highlighter to color code, which a lot of you did in this unit. I'm going to color code our missing side here, the yellow side, which is over here, it corresponds here. And we can use either this blue side with its corresponding number, or we can use the 4 and the 12 which correspond. So it doesn't really matter, but I think a lot of you can instantly see that 6 times 3 is 18, so you can look from here to here, or you can consider the green, but the green also is a times 3 situation. So basically this second shape is 3 times bigger. The scale factor here is 3, it's just 3 times larger. And we can now just do 5 times the 3 to get the missing side here. It has to be a 15. Now, a proportion we could have used to set that up, we could have said that the 6 goes with the 18. That's for my folks who see the blue numbers that match up. And then you could have said that 5 goes with our unknown side. And here we can cross multiply and divide. And so if we do 18 times 5, and then we divide that by 6, you can see we get the same answer, the 15. Friendly reminder for my folks who see the green sides that you could also have done 4 divided by 12. That 4, this matches up with the 12. And then the side that we have is 5 here that matches up with our unknown. And so again, cross multiplying and dividing will work. This time we'll do a 12 times 5. And then when we divide it by the 4, you can see we get the same answer. So no matter which proportion you set up, which set of sides you use, we're going to get a 15. And again, instead of using the scale factor, or sorry, instead of using the proportion, we could have used the scale factor, which is just to do times 3. All right, so then for the next one, ABC is similar to EFD, and then we want to find the length of AC. Now side AC, I can point out that AC should correspond with ED. So from A to C, it corresponds here with this side here in green. And then it looks like, so E to F, which is the first 2 letters, corresponds with AB. So I'm going to put this side in blue. And then BC, which is the last 2 letters, corresponds here with FD, the last 2 letters. So I can put that side in red. Now, if our goal here is to find this side, it's up to you. You can use the blue matching and say, okay, so 28 goes with a 4. And then I'm going to use the green unknown to match up with a 3. My folks in red, you would say that the 35 turned into a 5. And again, you would say that the unknown then turns into a 3. So it doesn't matter which ones you're using, we're going to get the same answer. And some of you, depending on how good you are with your times tables, if you're really good with your 7s, which not a lot of us are, but some of you might have caught that 35 divided by 7 gives me this 5. Here's the divide by 7 thing. Or you could think of 5 times 7 to get me 35. It works over here. 4 times 7 gives me this 28. So I could just do times 7 here to get this answer. That's using the scale factor. That works. But if we want to prove it by just cross multiplying and dividing here, I'll do the 28 times 3. And then I'm going to divide by 4. And that's a 21. So this side has to be a 21. And again, I can prove it by cross multiplying and dividing, or seeing, okay, so scale factor here is times 7. So 4 times 7 is 28. 3 times 7 is 21. 5 times 7 is 35. So 3 times 7 would be 21. All right, now we've got a trapezoid example, and we're going to use the corresponding sides to find x. Now, the first time around earlier in the school year, you guys did see this problem, and a lot of you got it wrong because you did not correctly match up the sides. Some of you fell for it and thought that this red side was corresponding with this one right here. But you'll notice out of the trapezoid, this one is the shorter of the two parallel sides. So this one here is the shorter of my two parallel sides. And then I don't think anybody's going to have an issue with those corresponding. Okay. So we basically want to say that the 7.2 turned into 3.6. We're going to set up that proportion. And the x turned into a 4.4. Now we're just going to cross multiply and divide here. I've got 7.2 times 4.4. All right. And now I'm going to divide by the 3.6. And we get 8.8. So x here is 8.8. Now that we have the answer, some of you might realize that if we took a 36 and doubled it, we'd get a 72. So again, 3.6 times 2. So 4.4 times 2, and we get the same answer. Now off to the side here, I've got just like a couple of proportions set up to show you guys that you might see these types of things on your SOL where it just checks to see, like, is this true or not? And I want to show you guys how to read these and remind you how this works. So for this one, we're saying EH and JM. So it's say go from E to H and J to M. And then the next one says FE and KJ. So FE, KJ. This works. This is a true statement. This does show that these sides are proportional. And again, to prove it, we could say EH, so second to first, matches with J to M. That's true. And then FE, it's saying so third to second, and then K to J, which is what that's saying. So again, looking at the similarity statement or looking at the shapes, we can see that this is true. Let's look at another one. This one says so H to G. So from H to G is right here, and then GF. So basically it's going within a shape. It's saying from H to G and then G to F. So from H to G and then G to F. That would be the same as going from M to L and then to K. So ML, we can see right here, and then L up to K. Yes, that's the same thing. So both of these are true. It can say match up blue to blue and red to red, which is what's going on over here. Or within a shape, it can say this bottom to this side, which means this bottom to this side, and those are proportional shapes. One other thing to review briefly is that the angles would also be the same. So for example, if we know angle E, which is the second one, it corresponds to angle J. So this angle and this angle should be the same. If it tells us that angle E over here is 105, we know that angle J right here is the other one that is also 105. So this one would be angle J, has the same angle measure as its corresponding angle E in the first shape. Now one last example here. So triangle SUN is similar to triangle FOX, which is again the same as seeing SUN is similar to FOX. So which side in triangle SUN corresponds to side OX? So OX is the last two here. So it would be side UN right here, which is answer choice C. We don't need to see the shapes to prove that. We can just use the similarity statement to identify corresponding sides and angles. All right, and that concludes this video. Thank you for watching.